mention one fact because I'm really impressed with it. He's leading the Institute of Communicating Information and Cognitive Systems, which has over 1,000 graduate students at the same time.
Yeah.
Wow, that's really impressive. Okay, are you ready?
This is ready. Thank you for the introduction, and thank you everybody for being here. I wasn't supposed to be here to present this. One of the other doctors that really did the work should have been here, but unfortunately they couldn't make it last minute. So here I am, and yes, this work that I'll present to you, and I'll try to be really fast due to the time, is part of a bigger agenda of trying to figure out what exactly matters when we try to understand the quality of 3D and what will make 3D tick. And it's only a small portion, and I'll explain to you what exactly it is. Basically, as you all know, in order to see 3D, we try to use two views and send it to different views to the two eyes, and then a lot of other stories happen, but that's how we see 3D. So two views that we need to capture. And of course, today we use different ways of seeing them. Unfortunately, with glasses, active glasses, like some manufacturers choose to use active glasses. Some others passive, which is polarized glasses, like most theaters use. So you polarize the two views, so you can separate them. And finally, of course, something that is futuristic, but hopefully it will work at the end of the day. Because I strongly believe that if we reach the point where we don't have glasses, then 3D has a chance to succeed. And those methods can be the methods of lenticular lenses that have in front of them, or another example of barriers in front with different LCD panels, and try to show multiple views. So here what we try to understand is what really makes a good 3D picture and what different factors may affect it. And a lot of those factors are listed here. The size, the scene, of course, but details are there, and how much motion may affect the quality. Contrast and brightness are the two factors that I would like to mention in this specific presentation. And of course, the display technologies. What kind of technology we use in order to show you 3D. The three different displays, or technologies if you want, active glasses, passive glasses, or polarized, and non-glasses really affect how you see the image. And we'll concentrate on the brightness and the contrast. So the objective here is to see how the brightness of an object which is of interest. For instance, if I'm sitting here and nothing else is moving, hopefully I'm the object of interest for all of you. Of course, when I was sitting down there, I was looking at the other side, but that's a different story. But I'm the object of interest, and everything else is the background. So the brightness of the object of interest, and of course the contrast between the object or the objects of interest and the background. And in all that process, we try to keep the background constant and try to really create data that will allow us to evaluate all this. So imagine that what we try to do is, if you look at this image, this is the object, the background stays the same. From brightness point of view, we try to videotape it that way, and then we'll try to evaluate what exactly makes a difference. And for two different technologies, the active glasses and the passive, we leave the glasses free out because it's a lot more complex to do the evaluation. So what we've done is we've done a lot of work in trying to prepare the data. We have a nice studio and we can do it. We received from the government of Canada about $25 million to set up a prototype lab in the building, because the unit that I lead in the university, which is kind of unique, it oversees about 18 departments and 7 faculties. It's mainly multidisciplinary, so it brings everybody together. And the building itself has 1,000 students that work in different projects. So what we used two cameras, we put them side by side like most of you do, of high quality. We avoid zoom in between, so we have the two, probably the two settings, no zoom or full zoom, so we don't have too much of changes to make, although it's possible. And of course, we synchronize the cameras with the same remote control. So here's what we do really fast because we run out of time. We try to capture different scenes at 6 different levels of brightness. Look at the background, although it doesn't look like it stays the same. We use sophisticated light meters to measure the background light, it stays almost the same, and we change the light of the object. In this specific case, we use different lighting mechanisms and devices that we have. When you go outside for outdoor scenes, of course, we use reflectors and other means to be able to change the brightness. And we do it at 6 different levels. Now, other things that we've done was 8 scenes for different indoor and outdoor areas. So these are the snapshots of the different scenes that we had, out of many, because we had to capture a lot to have a good understanding of an average what exactly it will give us. And the first thing that we measured was the response of the display. It's one thing what you capture when you go out and you're Hollywood and you're capturing a movie and you measure the light and you know what light you measure and you have some values. But then when you put it on the TV has a response. It has a different way of showing a pixel that you captured on the screen. So you really need to take that into consideration when you say, well, go out and capture that many candles per square meter. Well, that's not what the viewer will see when he or she sits in front of the TV and does the evaluation. We have to really consider that too. So we try to map the pixel value with the luminance that is perceived by the users, and we need to know the display response. For most displays, this is the equation. It's of course, as you can see, depends on what you captured, but there are a lot of constants and the gamma factor, of course, that depend on the technology that you're using. More details we can discuss if you want after this. So here you can see the two, well, I don't know if you can see it, but you're supposed to see 2 different lines that show the responses of the display system for the active, with active glasses, and the passive glasses. If you look at the right-hand side, I don't know if you can see it from down there, but if you look at the right-hand side, although they look alike, look at the y-axis. The y-axis on the left-hand side is from 0 to 5. The other one is from 0 to 70. So you can see that the passive technology is a lot brighter than the other one. Okay, so let's continue. That's what exactly you see. Of course, what we measure is we use a light meter and we put the glasses in front of it too. Because not only the display affects what you're displaying, but when you use glasses to watch 3D, you have to take into consideration how much the glasses themselves also affect what you're seeing. So we put the glasses, the active glasses or the passive glasses in front of the mirror, and that's how we measure the response, not just of the display, the actual TV set, but of the whole display system, including the glasses. Okay, and that's what you see here. And that's important. We follow, for the tests that follow, we follow the ITU 500 standard, which we used for the MPEG standard that we're testing now, is EBC and everything else. 18 subjects, 5 females and 13 males. We have more males apparently in our test because we couldn't find too many females. Forgive us for that. They didn't have much knowledge of 3D, so we put them in front of the TVs and we showed them a few things so they can understand, and we screened them for all the color, visual acuity, and of course stereo vision, and they were ready to do this. So really fast, what we did is we showed the videos, and then in between we had the gray, based on the standards of what you have to do. You put some part of gray content for 3 seconds, so the viewers can have the time to not only evaluate what they've seen, but also the time to relax their eyes and get ready for the next video. And the evaluation was a combination. They really understood that they had to see the naturalness of the video, the depth impression and the comfort, and all of them together, and then do the evaluation. So it's a combination of all of them. Fast, what we've done here is, I don't know if you can see it. On the left side is the passive, all the videos, different videos and everything. You can see that it's 10 to the power of 1 and everything is here. You can see that the passive is a lot brighter than of course, than the active, but viewers, as you can see, the means of the opinion scores like it if it's brighter. And that's something we all heard in the past, like brighter makes it look better in 3D. Well, it does. And really, the passive looks a lot better than active. But remember that because the background looks the same from a brightness point of view, what we change all the time is the objects of interest. So the overall image is what really matters, and that's what the viewers have seen. But that's not enough. We would like to also look at what really matters when you look at the contrast. And the contrast is the contrast between the object of interest and the background that stays the same at different brightness levels. Now when we go here, there is no candle per square meter anymore, because the contrast is the brightness of the object minus the background over brightness again of the background, so you have no units. But if you look at the active and the passive, and I'm not sure if you can see it again, anybody, can you see anything on this screen? Roughly, let me see if I can find something to show. No, I can't. Apparently it doesn't allow. No, sorry. I'm going to show you this escape. What is the weather now? It made my screen a lot smaller, so I don't know where to find the. Unfortunately, guys, I cannot show it to you. At the end, if you're really interested, I can try to show you. But what you're supposed to see here is that the contrast on this side and the contrast on the other side are different, and the actual values that you'll see is that the active display is acceptable above 6 to the users between minus 0.5 and 1.5 contrast, and the passive one goes from minus 0.5 to 3, and that's the difference. So definitely the passive glasses and the passive system outperforms the other one. So that's the result from these tests. Of course, there are tests to be done for TVs without glasses, but overall brightness matters, contrast matters, and the result that we get out of this small talk, because it's a much bigger picture, is that polarized systems can give you a better quality when it deals with brightness, not with everything. I'm not saying that the passive system is better than the active. There are other cases that the active can be better, but just regarding brightness and contrast, it really outperforms the active glasses based. So thank you for your attention. Hopefully I didn't overdo it. If you need to know more about the projects, there are about 30 projects on 3D that are running now. That's the website that you can go to and check for the media lab and all the tests that we're doing. Thank you.
Okay, thank you. Is there a question in the audience? Sure.
Yes.
Right. For your experiment, if you suppose that if you do the same experiment but to make the image content as a 2D, do you expect the result to be?
It's very similar.
So
And that test is also on the website, so you can see the 2D and 3D follow exactly the same in brightness. As long as you look at the 2D, very similar, surprisingly, as long as you can see the 2D using the glasses again on the same system.
So which means that probably your result maybe the effect of the 3D display, not the 3D content. Right?
Yes, yes, absolutely. I never said anything about depth, nor of anything else, but it's how the 3D system affects the quality, and how brightness is important, but also in 2D.
Is there another question? So maybe I can ask one. Is it really a problem of the technique, so that the active shutter glasses make it dark, or is it a problem of the product you use?
No.
It's really
we have
the same for all of them.
20 different TV sets in the lab, so this is an average result.
Okay. All right. Thank you very much. Oh yeah.
Yeah,
That's
so
another
this is
question.
one of mine, but I'm asking about what's the product, because depends also on the product. They can maybe add some LED screen insertion between the two sequential.
We used 5 active classes and 2 different passive classes, and if you allow me, because it's consumer electronics, we should not be using names of products based on what they tell me, and I'm following it. But the passive classes that we used, and it outperformed the other one, is the TV that we chose from the MPEG to do the test for 3D. More on one-to-one